Look at this board. If you pull up your hands, answer our questions, or share your points, and you can get scores. And the scores you higher, and our gifts will better. And I will make a self-introduction. My name is Ricky. I'm a technical support engineer of INVT. And have you ever used our product?
Yes.
Which product have you ever used? All the products. Okay, let's start. Our introduction is divided into 3 parts. Part 1, product introduction. Firstly, I will make a brief introduction of GD27. GD27 is a smart VFD newly developed by INVT, supporting SVC and VF control, drive synchronous and asynchronous motor, heavy load design, book-type structure, and it has standard built-in brake units and plentiful accessories. Look at this picture. GD27 has 3 power ranges, so it has 3 sizes. Product feature. It has heavy load design. It can work for a minute at most under the condition of 150% load. And the capacity, the overload capacity is same to GD20 and GD350 and other products. And it supports vector control and has excellent performance. It supports synchronous motor and asynchronous motor. And it has book-type design, so they can be installed side by side, so it can save space. Optional rail mounting, dismount easily. And it has natural heat dissipation design, so it has no fan and no need to maintenance. And when it's running, it's very quiet. Configure on demand, save time, and it has built-in brake unit standard. So you don't need to buy another brake unit, and it can save space and more economical. Terminal cover standard, beautiful and neat. Push-in terminal, you can use a screwdriver to push the terminal, and it's easy to wiring. And the last one, external parameter copy keypad. Only partial power supports it. Easy to debug. GD27 has 3 main advantages: small size, economical, and excellent performance. So this is GD27. It looks so small, and it's the next generation product of GD20. It's smaller than GD20, and it's more economical, but the performance is not reduced comparing with GD20. And the GD27 update firmware. Look at this picture. The upper port is for control board, and the below port is for drive board. When we burn the firmware, we can use a micro USB wire to connect this port with your computer and burning software tools. And be careful, don't connect this port with your computer directly, because it has strong electricity. So if you connect it with your computer directly, it may damage your computer or other devices. Difference of keypad between GD20 and GD27. GD27 keypad is smaller than GD20, and GD27 only have six buttons, and the GD20 has 8 buttons. But the functions between GD27 and GD20 keypad is same. The difference lies in the operation ways, and I will give you detailed instruction in the afternoon. Difference of function. First one I have mentioned it about, and EMC filter. GD27 EU has built-in EMC filter, and GD20 only about 4 kilowatt has built-in EMC filter. Port GD27 only has one analog output and two relay output. And for GD27 EU, it only has one relay output because it has STO function, and the STO function occupies the location of relay output. And the range of output frequency and ambient temperature, GD27 is wider than GD20. And the installation mode, GD27 support wall mounting and rail mounting. We need to notice that the rail mounting only support A and B sides. GD27 also support natural heat dissipation, and GD20 don't support it. The last one, and the wiring mode. GD27 select NPN and PNP by P05.54, and GD20 select it by short joint. And the phase loss detection, GD27 achieve it by using software, and the GD20 achieve it by hardware. Okay, this is part 2. Control mode and relative parameters. Firstly, I will introduce VF control, and look at this curve. This is VF curves, and it including straight VF curve, multi-point VF curve, and torque down VF curve. For constant torque loads such as straight running conveyor belts, the straight VF curve can be selected, and curves 2 to 4 are suitable for torque variable load of fan, pump, and similar equipment. Multi-point VF control. A multi-point VF control. In order to adjust the motor's output voltage flexibly at different frequencies, multi-point VF curves can be determined according to the actual load characteristics. And when we use multi-point VF curve, we can adjust the curve on the host controller. Our host controller name is workshop. And the next one, VF separation. When we use VF separation, the VFD is often used as an AC power source, and the acceleration time usually set very small, so that the running frequency can reach to the set frequency very quickly. Torque boost. Do you know why we use torque boost? Because torque boost can raise the output voltage at a low frequency. And look at this curve. After using torque boost, the output voltage has raised obviously. Oscillation control. When the VFD runs in VF control mode, it will generate motor oscillation in high power occasions. And how to eliminate the oscillation? We can try to set P04.10 and P04.11. And they are low frequency oscillation control factor and the high frequency oscillation control factor. And by adjusting these two parameters, the oscillation can be eliminated. And the next one, P04.12, is oscillation control threshold. The default value of it is 30 Hz. So if the VFD is running in 30 Hz and it has some oscillation, maybe it's related to the P04.12. So you can adjust the threshold, and you can adjust it to 35 Hz or 25 Hz, and the oscillation will be eliminated. Synchronous motor control. Here we mostly use pull-in current. Pull-in current can increase the stability of our VFD at low frequency. And if you want to increase the response speed of pull-in current, you can raise these parameters P04.37 and P04.38. They are proportional coefficient and integral time. If you have used PID control, and this parameter is Kp and another one is Ki, so we can increase Kp and decrease Ki, and to increase the response speed. Speed loop. In this section, speed loop proportional gain and speed loop integral time is the main parameter. We can adjust them properly, and the stability of our VFD will raise, and it can be suitable for so many motor characteristics. And the P03.6 speed loop output filter, we can increase the value of this one, and the stability of output current will increase. The next one, cart loop, is related to the stability and the response speed of our VFD. We often use pre-excitation. It is used to establish a magnetic field inside the motor, and in order to improve the torque characteristics during the starting process. So it's very important to use pre-excitation. If you don't use pre-excitation when starting, it may be cause the startup current very high, and the motor may be out of control. Flux weakening. When the motor speed is running above the rated speed, the motor will enter the weak magnetic operation state. And we just need to adjust the P03.22 and P03.23, and to adjust this curve so that the output voltage can be adjusted. And synchronous motor control. Here we also use pull-in current to increase the stability of VFD at low frequency. And if you want to increase the starting torque, you can increase P13.02 appropriately. And if the motor is no load with vibration, try to reduce the value of speed loop Pi. And if the problem still can't be solved, injected current can be increased appropriately. Okay, last one, synchronous motor pole detection. In the case of high starting equipment, the motor is not allowed to reverse during the startup. It's not allowed to reverse. So we can set this parameter P13.01 to enable the initial pole detection. And we can set it to 1 or 2. And then the reverse will be eliminated. And in some cases, the reverse is allowed, but the noise is not allowed. So in this case, we can't enable the detection, initial pole detection. We need to set it to 0 to eliminate the noise. And now I have some questions. If you want to answer, you can put your hands up. What's the effect of pull-in current? Does everyone know? Okay. Pull-in current can raise the stability of our VFD at low frequency. It's about stability. And do you know what the effect of torque boost?
Increase the torque at the start.
Oh, yes. Oh, I will give you a score. Hey. Okay, let's go on. Next part. The last one is FAQ. When we commissioning, we may meet some issues, and the first one is unable to start. Here we discuss the channel of running commands is a terminal. We use terminal to control the VFD start and stop. And so firstly, we need to check P0.01, the channel of running commands. Because if the channel is wrong, the terminal will not work. So next one, we need to check the running signal. Because if the signal is not sent to our VFD, the terminal will not work. And the next one, VFD is already running, but there is no frequency reference. Maybe it's set to 0 Hz, so the motor does not rotate. And in this case, we need to check the state of VFD to confirm if it is running. And the next one, check the status of the input terminals, such as we use S1 terminal to control start and stop. And we can check the status of S1 if you give it the running signal and then the status of S1 has changed. It means that the VFD is okay. And if the terminal state is not changed, maybe the terminal has broken or your running signal isn't sent to the VFD. And if the above points does not work, you can try to restart the VFD. Maybe it is deadlock, and restart it can make it work normally. Next one, the frequency set by AI is incorrect. Look at this picture. Here we can choose the type of AI and AO by using this switch. And the left is ampere and the right is voltage. Firstly, we need to check P0.06, setting channel of A frequency command. AI set it to AI, so the frequency can be set by AI. If you set other, such as a keyboard to a keyboard command, the frequency will be incorrect. And then confirm the type of AI. Is voltage or ampere? And then check whether the switch of AI is right. And if the signal is special, we often use 0 to 10 volt. And maybe some occasions we use 0 to 5 volt. P05.32 and P05.34 should be set to 0 and 5. Last one, check the value of P17.19. It's AI1 input voltage or measure it with a multimeter, we need to check whether the voltage is right. Next one, motor auto-tuning fault. Firstly, we need to make sure the motor is properly connected to the VFD, and then check whether the motor capacity and the VFD capacity match. If they don't match, the auto-tuning parameters will be improperly. And then check whether the P02 motor parameters has been set correctly, such as the motor voltage, speed, and the frequency, power, and the current. And the last one, we need to check whether the output voltage and the current are normal, and confirm the VFD hardware is faulty, whether the VFD hardware is faulty. Next one is a little hard. Asynchronous motor VF control. When we use this, and we may meet some problems or phenomena, and here is some solutions. First one, the output of motor is insufficient or unstable at a low frequency or during startup. And we have mentioned about that the torque boost can raise the output voltage at low frequency. So we can change the automatic torque boost to manual torque boost, and it is generally recommended to set to below 3% for low power VFD, and for high power VFD we set it to 6%. And next one, the dynamic speed response is insufficient. We can increase the value of VF slip compensation gain and adjust the voltage value corresponding to the frequency of the VF curve appropriately. And next one, current oscillation, and during low frequency and high frequency, we have mentioned about that we use oscillation control factors to eliminate the oscillations. We can set it from 10 to 5, 20, 30, or 40. You can find a proper value, and it can eliminate the oscillation. And the last one, overcurrent occurs during running. We can adjust the oscillation control functions. Maybe it also affect the current. And for low speed overcurrent, P04.01 can also be adjusted. Okay, the last one, asynchronous motor vector control. The output of motor is insufficient, same to the this one, but the control mode is not same. So the solution is increase stator resistance and increase electromotive slip compensation coefficient. And we can enhance the coefficient of low frequency speed. I have mentioned is Kp and Ki. We can raise Kp and decrease Ki. And we can also increase P02.10 and decrease P02.09, ensuring that the product of P02.10 and P02.9 remains basically unchanged. And I will explain this one. We use P02.09 and times P02.10, and the value of X is stable. We can adjust this value and this value, but X can't be adjusted. And the dynamic speed response is insufficient. We can increase P03.07 electromotive slip compensation coefficient and enhance the adjustment effect of low frequency P03.0 and P03.01 and high frequency speed loops, ensuring not to cause motor vibration or abnormal noise. We can also increase the rotor resistance and increase P03.20 and P11.06. Last one, overcurrent or unstable occurs during running. We can adjust the motor parameters by increasing P02.10 and decreasing P02.9 and ensuring that the product of P02.10 and P02.9 remains basically unchanged. And I have mentioned here, we can also increase P03.20 and P11.06 and increase P03.24. Make sure that it don't exceed 106%. We can also adjust the current loop P03.09 and P03.10. Okay, the introduction is end. And do you have any questions? Eddie and me can answer to you.